Hello everyone, let's study about scattering of light. Scattering is a phenomenon where a molecule, or in general called as a scatterer, absorbs radiation of some wavelength and re-emits it in all directions with same or different wavelength. That's called scattering. So to understand this, let's assume that you have a small particle like a air dust, or like a, for example, like say mist or something else. If light falls on it, imagine that there is a photon which falls on this scatterer of wavelength lambda. Now this scatterer would absorb this radiation and re-emit it. Now this scatterer may re-emit one wavelength or many wavelengths. Let's assume that this scatterer emits few wavelengths called as lambda 1, one more called as lambda 2, and one more called as say lambda 3. So in this case, the scatterer, that is this molecule here, is absorbing one wavelength and re-emitting in all directions. Sometimes the wavelength could be same or different also. So in this case, as seen here, the wavelengths are different. This phenomenon is called as scattering. Now every medium or every body will not scatter. For scattering to be visible, the condition is that the object's dimension would be its length or diameter. Its dimension should be comparable to the wavelength order. For visible wavelength, the order or the range of wavelength is from 4000 angstrom to 6500 angstroms. That will be from 0.4 micrometer to 0.6 micrometer. So whenever the scatterers or the particles dimension is of this order, then you see scattering. Generally, the particles like particulate matter in the atmosphere or soot or dust, these particles are of this order, hence it is visible in nature. In case of sound, scattering is more visible because the human range of sound to be heard is between 20 Hz to 20 kilohertz. So this is the range of audible frequency. Assuming that the sound travels with a speed of 343 meter per second, this corresponds to a wavelength of 17 meter to 70 millimeter. Many objects around us, like the door wall or the switches, these are on this order only. That's the reason that scattering is more prominent. We find scattering of sound very prominently around us than light because of this range. Now, if the order of the object is very big, then light would be reflected. Let's understand about Rayleighs formula. Now this Rayleighs formula or Rayleighs criteria is very important to understand certain things we see around us in nature. Before going into what those are, let's understand what is Rayleighs formula. According to Rayleighs formula, the intensity of radiation is inversely proportional to the fourth power of wavelength. So if we have a wavelength of certain value, then the intensity what we receive would be going as 1 by lambda power 4. The proof of this is not required for class 12 level. Just learn this formula. The intensity of radiation is inversely proportional to the fourth power of wavelength. Now based on this, we have two important natural phenomena. The first one is to understand as to why does the sky appear to be blue. It's very common sense that whenever we look at top, we look at outside the home, when you come and look out on top, we find a blue color envelope. That's what we call as sky. So the appearance of blue color is because of scattering only. To understand this, we know that the intensity what we perceive is given as 1 by lambda power 4. If we look at, say, white light from sun, the colors would be in the order of Vibgyor, which stands for violet, indigo, blue, green, yellow, orange and red. You also know that in this order the wavelength is increasing, which means violet will have more frequency and less wavelength, and red will have more wavelength. So in this order, violet will have less wavelength and red will have more wavelength. Now because of this reason, since intensity goes inversely as 4th power of wavelength, the intensity of violet, indigo, blue would be greater. It's a reason that we find more of these colors. So since violet, indigo, blue have lower wavelengths, they'll have a greater intensity. Now the question is, why don't we see the sky as violet or indigo? There are two reasons for it. The first reason is, human eye contains some specialized cells called as rods and then cones. Cones are the cells which are used for detecting colors. Whatever color we perceive is because of the cones in the human eye. Now because of evolution, human eye, that is cones, are more sensitive to blue color than violet color. That is, human eye can perceive more of blue color than violet color. That's the first reason. The second reason is, if you plot a graph of the solar spectrum, that is a graph of the frequency of light with intensity along the y-axis, and you find that the intensity of light is more for yellow color. That is why sky appears to be, that is why sun appears to be yellow. And also look at the amount of blue being emitted. That is, sun emits more of blue than indigo or violet. Since sun emits more of blue, there is more blue present around us. Since more blue is present around us, we perceive the sky to be blue. But keep in mind that the appearance of the sky to be blue is only because of scattering. If the atmosphere is not present at all, if nothing was present, then you wouldn't find scattering at all. You wouldn't even find the blue of the sky. So scattering plays a very, very important role in nature. The second observation is, or the second phenomenon is, to understand as to why does sky appear reddish orange during sunrise or sunset. It is common experience that most of us would have seen the sky around the sun to be reddish orange or yellow during sunrise or sunset. To understand this, let's assume that this drawn here is the atmosphere, and imagine white light coming from sun. Now if you look at it carefully, when you say sunrise or sunset, it means that the sun is just above the horizon or just below the horizon. Example, in this case, if you perceive or if you think this is like the earth's surface and this is the horizon, then if sun is somewhere here, say it's somewhere just risen, then what happens is the sun travels, as seen here, the sun travels more through the atmosphere as given here. It travels more through the atmosphere. This is in contrast to a condition where the sun is overhead. If you assume that sun is somewhere here overhead, then what happens in this case is the sun travels less through atmosphere. So the sun travels less distance to the atmosphere. So compare this distance with this distance, very obvious that whenever sun is above head, it travels less distance. Now, since the sun travels more distance when the sun is just risen or about to set, and what happens is, since the colors like blue, violet, indigo are scattered more and more, they have more intensity, they don't even reach the Earth's surface. If visualize this to be like a human eye, then these colors are so much scattered that they don't even reach the human eye. As seen here, you could see that there is violet here only, there is blue up to this part, indigo, there is blue up to this part. So these colors don't even reach the human eye, but the colors which are less scattered like red, orange, yellow, they reach the human eye. So even the appearance of reddish orange is because of scattering only. This is the reason that in traffic signal we find red color to be used to mean to stop, because since red color is less scattered, even from far away it could be seen. Imagine what would happen that if blue or violet was used to mean to stop, then from far away it can't be seen, which would lead to accidents. So this behavior is again the reason that the sky appears to be reddish orange during sunrise and sunset.